Playing Gucci gang, spent 5 racks on these double frames, yeah, they look to hate.
Okay, good morning. Today for pre-calculus, I'm going to be looking at the sines of trig functions. I'm going to start over here on this chart, and the sine is positive in certain quadrants and negative in others. So is the cosine, and so is the tangent. These are actually pretty easy to keep straight if you remember, or remember in the future, that the cosine is always the x-coordinate and the sine is always the y. Which means if I was going over here and I was to say, for example, say I'm in the third quadrant and I put a point there, any point in that quadrant, I threw the point -1, 1 in there. Any point in that quadrant, the x-coordinate is going to be negative and the y-coordinate is going to be positive, okay? It could be -5, +6, which would, be up here somewhere maybe. But anyway, the x is negative, the y is positive, which means the cosine is negative and the sine is positive, okay? In the first quadrant, everything is positive. In the second quadrant, the sine is positive, the cosine is negative. And remember, one of the definitions for tangent is that if you take, is like y over x. So if I take the y coordinate, which is going to be positive because the sine is positive, and I'm looking at the second quadrant here, and then divide it by the cosine, which is a negative, you end up with a negative. So you'll end up with negative in this tangent in the second quadrant. The third quadrant, both the sine and cosine are both negative. So if you take the negative, divide by a negative, you get a positive tangent. Okay. Sine is in the fourth quadrant, sine is negative, cosine is positive, and tangent is negative. All right. So anyway, also, if you end up getting theta on the x or y axis, then we use the corner angles, and I went through this in the last lesson with you guys. Remember the points here on the axes would be like 0s and 1s or -1s. So this one over here would be, I didn't write in the degrees. This would be 180 degrees, right? This is 270. This is 0 or 360. And up top is 90 degrees. All right. Degrees there. Okay. Yeah. So that's the idea. Okay. So we're going to keep referring back to that because some of these problems, like for example, number 1, they're telling us that immediately that I'm going to find the other 5 trig values first of all, but they tell us that theta is in the third quadrant. So the third quadrant will be down here, which means, the sine is going to be negative, the cosine will be negative, and the tangent will be positive, okay? So you can either keep referring back to this or you can memorize them or whatever. Okay, so first thing I'm going to do, I'm going to draw a triangle because I'm going to need that third side of the triangle, okay? Remember, there's a right triangle, which means Pythagorean theorem is the easiest way to find the third side of any right triangle. Cosine is the adjacent over the hypotenuse. And maybe I'll show you a couple ways to do these kind of problems. So if I go, what is that missing side over there? That's either A or B. But what is important is that 13 has to be C because it's the hypotenuse. And if you solve that out properly, you get A is 5, okay? Move this down below. Okay, so let's see. I've got the cosine. And they want me to find the other 5 values. So I'm going to put secant across from cosine because those two are inverses. Sine and cosecant. I'll put those opposite each other. And then, of course, tangent and cotangent. I'll put across from each other. So I like to kind of do the signs first, okay? So I don't have to keep, believe it or not, it's the easiest thing to get wrong. For me, I'll drop the negative is what happens. So I'm in the third quadrant, just like it says right here in the information that's given. So I'm over in the third quadrant here, which is bottom left. So sine, cosine are both negative, and tangent is positive. So let me put those negatives in there now. Sine, cosine are negative, and tangent, I'll even put a plus there. It's not wrong to put a plus. Now, cosine and secant, those are inverse functions, but doesn't mean they're going to be the same sign, okay? So now I got to find out the numbers, the ratios. So cosine, remember I'm looking at theta here, is adjacent over hypotenuse. 12 is the adjacent, 13 is the hypotenuse. Gives me negative 12 over 13. Next is sine. Sine is opposite over hypotenuse. Opposite is the 5. And 13 is the hypotenuse. Gives me 5 over 13. Tangent is opposite over adjacent, which would be opposite is the 5, adjacent is the 12. Okay, now that I've done that, the inverse functions will be a piece of cake. I can just flip these upside down. I've already got the negatives taken care of. So this one's 13 over 12, this one's 13 over 5, this one's 12 over 5, and I've got my answers there, okay? Okay, next one, same idea. Theta is in quadrant 4. You know, I'll show you a different way to do this also. If I draw this, my triangle, you can do it this way. Fourth quadrant is down here, which means my angle goes down here. And here's the right angle. Theta always goes between the x-axis and that line I drew in there, okay? Which means sine is opposite over hypotenuse, which is 2/5. Now I know that 2 is negative because, you know, this is negative 2 on the x-axis. This is, the 5 is the hypotenuse. The hypotenuse is actually never negative. So I can go like this. This is another way to do these problems. And if you didn't like this, you can go right back to what we did up here, you know, where you go back to the chart and you say, okay, in the fourth quadrant, the sine is negative, cosine is negative, and tangent's positive in the fourth quadrant. Sorry, cosine's positive in the fourth quadrant. So you can do it that way too. But let me show you this way anyway. So let me see here. I got sine of theta, cosine of theta, tangent, theta, and then the inverses. Cotangent. Now they gave me one. They gave me the sine is negative 2/5. Now I need the third side of that right triangle once again. Okay, so I'm going to do Pythagorean theorem. And if you do Pythagorean theorem correctly, 2 squared plus b squared equals 5 squared. And you solve that out, you get square root of 21. Okay, and obviously that's a positive one because that's going on the positive side of the x-axis. All right, so now I've got the negative all in there. I actually don't have to worry about it. You'll notice now that if I'm looking, for example, for the cosine is the adjacent over the hypotenuse, which is the square root of 21 over 5, or tangent, which is opposite over adjacent, which is negative 2 over the square root of 21. Okay. And these are obviously going to be the inverse. But notice how I got the positive and negative parts right just by doing it that way. But like I said, if you don't like that, that's fine. You can go right back here and see that the sine in the fourth quadrant is negative, cosine is positive, tangent is negative. Okay, now I'm just going to flip all these upside down and I'll get all my other answers. I usually get this question, Mr. Flory, does it matter whether the 2 is negative or the 5 is negative? Remember, this is a fraction. So a positive number divided by a negative number is negative. a negative number divided by a positive number is negative, and if I put the negative sign in front, then you're taking the whole fraction and making it negative. In other words, it doesn't matter where the negative sign is, whether it's in the top of the fraction, the bottom of the fraction, or out in front of it, as long as there aren't two negatives, because that's the one that's different, right? Negative divided by negative is positive, so as long as you don't have that, the rest will be okay. Okay, so there's the rest of my answers. I just flipped them to get the inverse functions, okay? Next one, number 3. So this one, usually I don't really work too much with cosecants and secants and cotangents. I work with the original ones, since those are the inverse functions, which means the inverse of the cosecant is the sine. And remember, I can flip that upside down. I can always put that over 1, because all whole numbers are over 1, which means the sine is actually 1/2. And then I'm going to do it the other way, where I just go back to my chart and figure out where the sign is positive and negative. Oops, so I'm not doing it that way. Which means I'm just going to draw a triangle. Got to put the angle theta in there. Doesn't matter where. You can, as long as you have the opposite be the 1 and the hypotenuse being the 2. Which means next I can do Pythagorean theorem to find that third side of the triangle. Right, 1 squared plus b squared equals 2 squared. And if you solve that out correctly, you should get square root of 3. Okay, so I got the sine, cosine, tangent, which means cosecant, secant, cotangent. So we said we're in quadrant 2, okay? So if I go back up to my chart here, quadrant 2, sine is positive, cosine is negative, tangent is negative. Positive, negative, negative. Sine's positive, cosine's negative, tangent's negative. Okay. So now I'm just going to finish solving it. Now I need my ratios, right? So sine, I've already got sine and I've already got secant. Excuse me, cosecant. Cosine is adjacent over hypotenuse. Adjacent is the square root of 3. Hypotenuse is the 2. Tangent is opposite over adjacent, which is 1 over the square root of 3. And remember, these will be just flipped upside down. So this is the square root of, oops, upside down, 2 over the square root of 3. This one's the square root of 3 over 1, or just the square root of 3. Okay, there's that one. Next one, number 4, tangent of theta is undefined, and theta, remember that's a compound inequality, is between 0 and pi. Okay, so if the tangent is undefined, it means I got a 0 in the denominator, okay? Which, remember that the tangent is y over x, which means I got an x value of 0. I don't know what the y is, but so when I see that the x's value is 0, I'm going back to that this up here where it's on the x or y axis, okay? So I'm looking for where the x is 0, which means there's where the x is 0. It could also be down here. However, that told me that theta was between 0 and pi. Remember, with radians, pi is 180. 2 pi would be 360. So it means it's in the first two quadrants somewhere, which means it's going to be the 90. Not the 270, okay? Because pi over 2 is 90 degrees, and pi over 2 is between 0 and pi. So that's going to be where my my answer is really like 90 or pi over 2, depending on whether you are in radians or degrees. know that it's 90 degrees, so now I need the sine of theta, the cosine of theta, and I have the tangent. It turned out to be 1 over 0, which means I'm going to have the cosecant of theta, the secant, and the cotangent of theta. So cotangent, that's pretty easy. 0 over 1 will be 0. Sine and cosine, if I go back up to my chart here, remember sine is the x value, cosine, backwards, it's alphabetical. So x comes before y, therefore cosine c comes before s, so c is x. So cosine is 0 and the sine is 1. Cosine is 0, sine is 1. Cosine is 0, sine, cosine, I got it backwards. Cosine is 0, sine is 1. Which means this is the same as 1 over 1, which means my cosecant is also going to be 1. Cotangent, I did 0, and secant will be, so this is 0 over 1, right, the cosine, which means if I take 0 over 1 and I flip it upside down, I get 1 over 0, which is going to be undefined, okay? So that was the kind of the tricky one. You know, one of those was going to be undefined. So anyway, there's the dead answer. Next one, number 5. Cosine of theta equals -1, and theta is between pi over 2 and 3 pi over 2. So when I say pi over 2 and 3 pi over 2, that's here's pi over 2 is 90 degrees, 3 pi over 2 is 270 in radians, which means it'll be somewhere between here and here. Okay? And if cosine is -1, once again, I see zeros and -1s. Those usually tip me off that it's going to be these on the corner angles. Cosine's -1. I'm looking right there. There's my -1 is the x coordinate at 180 degrees. So 180 is my reference angle. So my reference angle is 180. Okay. And well, that's theta. I'll get to reference angles in a little bit. It is a reference angle too, but equals 180. Okay, so I got cosine. I need sine, and I need tangent. Okay, so back to the 180. Back up here, 180. X coordinate is -1. Y coordinate is 0. X coordinate is -1. Y coordinate is 0. Y coordinate is the sine. Tangent is y over x, which is 0 over -1, which is 0. Okay, and now the cosecant and the secant, cotangent, these will be pretty easy. I'll just flip them upside down. Okay, so 0 over 1, I can always put that over 1, which means I get 1 over 0, which will be undefined. -1 over 1 is still -1. Cotangent will be -1 over 0, which is also undefined. So I had a couple undefined ones there. Okay, and those are my answers. All right, next one. So here's pi, here's 2 pi, which means the cosine of 0 is between those two, so it's somewhere between here and here. This is 3 pi over 2, which means, and remember I'm looking at coordinates here on the unit circle when I see those zeros and ones. So that point is 0, -1, which means Cosine is the x-coordinate, so that's the one I'm looking for, which is 3 pi over 2 or 270 degrees. We'll do the 270 degrees. I know you guys are still getting used to the radians thing. Okay, so I got the cosine. I'm going to need the sine, and I'm going to need the tangent. And then, of course, the other three. Okay, so sine is the y-coordinate, which in this case is -1. Tangent is y over x, which is undefined when I have a 0 in the denominator. Okay, so remember you can always put this over 1, so that gives me 1 over 0, which is undefined. Cosecant will be -1, -1 over 1. If you flip it upside down, it stays the same. This will be 0 over -1, which is 0, not undefined. It's okay to have the 0 in the numerator. Okay, those are the answers for that one. Next, we're going to talk about reference angles. Big topic here. What is the reference angle of the following? So the first thing is the reference angles are always between 0 and 90 degrees. And a reference angle is the shortest way to get to the x-axis. Okay, that's big. I put a star next to it. I should probably highlight it too. All right. The other thing is that if it happens to be an acute angle in the first quadrant, then that's equal to their reference angles. We'll see some of those coming forward. All right. What is the following angle? What is the reference angle of the following? Sorry. So first one, I'm going to draw this in what we call standard position, which means you always start at the x-axis and you go around. Okay, and remember positive angles always go counterclockwise, so they go this way. Negative angles go the other way. Okay, which means if I'm going around here, remember this is 180 degrees, this is 90, this is 270, this is 0 or 360. And you can go around the circle more than once too. Sometimes you might see that. But 211 is between 180 and 270, so it's somewhere over here, which means I'm going all the way around to there. Okay, that's my 211 degrees. Now the question isn't how much that is. The question is how much is the reference angle. And the reference angle, like I said, is always the shortest distance to the x-axis, which means that line right here is going to be my reference angle. And in order for me to get, in this case, if I just go 211 minus 180, I get my reference angle, which is 31 in this case. And that's the answer. Okay, so that's all I'm looking for. And that's my reference angle is 31 degrees in this case. Okay, next one. I'm going to do another one before I get to that one. So I'm going to call this 7b. Suppose I had 285 degrees. What's my reference angle there? Well, I'm going to draw this out again. Remember, this is 180, 270, 360, which means 285 is between 270 and 360. So it's going to be in this quadrant, which means I went around here 285 degrees. However, what I'm actually interested in is the distance to the x-axis, which means I'm actually looking for that. All right, so how much is that? Well, this time that distance will be 360 minus 285 will give me my reference angle, which in this case is 75 degrees, and that's my answer. Okay, now I'll go back to this one. 470. So 470 is more than once around the circle. Okay, so let's say I went all the way around once, that's 360. If I went around a little farther over here, I take 360 and I add another 90, gives me 450. And if I went another 90 over, I would end up at the over there, which is 360 plus 180 is 540. So those are my how many degrees it is. This one's weird because it went around more than once around the circle. However, I know that 470 is between 450 and 540, which means it's up here. Right? Now remember, the reference angle is always to the x-axis, the shortest distance to the x-axis. So that's my reference angle. Okay, which means if I subtract 540 and 450, I'll get my reference angle. Sorry, 470. That's 470. This is 470. So if I subtract those two, I get 70 degrees, and that's what my reference angle is. Okay. Next one, negative 268. So going in the negative direction this time. So here is negative 90. Here's negative 180. Here's negative 270, which means it's up there almost at the 270, but 2 degrees short, right? Which means my reference angle is always to the x-axis, which means if I subtract those, that was 2 degrees, which means this one's 88 degrees. And remember, reference angles are always positive, okay? So my reference angle is 88 degrees, even though, some of those are negative, okay? Now, last but not least for this particular part, I got a couple things to show you after this, but let me get to this. 11 pi over 6, if I was to turn that into radians, you can multiply by 180 over pi and simplify it. You'd find out that this is 330 degrees, and that's probably the easiest way to go about that one. Okay, so the 330 degrees is what 11 pi over 6 is, okay? And if I go over here and I draw 330 degrees, the standard position, I get there. So it's almost all the way around the circle, but not quite, right? In fact, it comes up, that's going to be my reference angle, that theta right there. So it's how much is that? Well, if you subtract 360 and from 330, or the other way around rather, remember the reference angle is always positive, which means 30 degrees is my reference angle, and that's it. All right, next, I'm going to talk about families of angles for a minute. 30, 150, 210, and 330 are a family of angles, okay? And 30 degrees in radians, there is pi over 6. So I listed all the radians below them, so 150 degrees is 5 pi over 6, etc., etc. What this means is, if I went over here and say this is, 30 degrees, and then this one would be 150 degrees, and if I took the next one, which would be 210, 210 would be this one. In other words, what happens is if I take 180 and I subtract the 150, I get 30. And if I take the 210 and subtract 180, I end up with all of these end up with reference angles of 30 degrees. That whole family of angles, okay? That's why that's a family. The next one, if I did with 45, 135, 225, and 315, you would find the same thing, that all of these angles have reference angles of 45 degrees, okay? And last but not least, 60, 120, 240. Here's 60, 120, 240. All of these will also end up with reference angles of 60. Okay? So that's what I meant by the families of angles. All right. Also, if you haven't already done it, you should memorize some of these radians and know these, okay? that 30 degrees is pi over 6, 45 is pi over 4, and 60 degrees is pi over 3. There's more radians that we have coming up, but if you can memorize those, everything else kind of builds off of those. If I take 60 and multiply it by 3, I get 180, which means pi over 3 times 3 is pi. Okay, anyway, that's it for me, and have a great morning, afternoon, evening, wherever you are, and see you soon.